Hi, this is Jeff Spence, Math 135 instructor for the Community College of Denver, doing a video today on hypothesis testing, the p-value approach. So I've written these steps on the board more than a couple times, but let's go over them again. For any hypothesis test, you need a null and alternative hypothesis. Big thing about the alternative is it tells you if you're looking at the left tail, right tail, or two-tail alternative. So that's important to note down. Then step 2, right after that, you compute your test statistic using the information given in the problem. So we have 3 different test statistics at this point. The one in orange where you're testing means and you know the population standard deviation. The one in blue where you're testing means and you know the sample standard deviation. And the one in purple where you're testing percentages where you use the z-data. Okay. Then after you compute your test statistic, you compute your p-value, which is the area from your test stat that you just computed into the tail corresponding to the alternative hypothesis. That's why we label the alternative hypothesis left, right, and two-tail. When you're doing the p-value, remember you're either going to be doing t-CDF or normal CDF. We'll do a t-CDF when we have a t-data and normal CDF when we have a z-data, the orange or the purple. Finally, you make your conclusion at the end. If your p-value is less than alpha, you reject the null. And if your p-value is greater than alpha, you fail to reject the null. That's the main thing you're going to have to remember, as well as the steps. The formulas in the middle, we give you. So let's look at an example. Suppose in 2002, 36% of CCD students had kids. We think it has changed, so we survey 130 students and find 50 that have kids. Test the claim at the alpha equal 0.05 level of significance. So, once again, we've got to start with the null and alternative. The null, we give you right away. 36% of CCD students have kids. So, that's it right there. And we say the null, h sub 0, is that p equals 0.36. Let's redo that. There we go. Okay. We think it has changed. That's the key word, changed. So that means we have a two-tail, not equal to. P not equal to 0.36. Alright, and so we survey 130 students, that's n is 130, and 130, and find that 50 have kids. So, let me go back. Since it's changed, we have a two-tail alternative. Alright, and out of the 130 that we surveyed, we have 50 that have kids. So that's how we create our p-hat, the 50 out of the 130. It wasn't an average of 50, it was the 50 that had kids. So we have to take that 50 out of 130 because we're working with percentages, and we need to convert all our information to percentages. So I take the 50 divided by the 130 and get 0.38. 46. Alright, so that's the p-hat. Now, it says test a claim at the alpha equal 0.05 level of significance. So I got to check my formulas, and it looks like I'm going to be using the purple formula, the z-data with p-hat and p, because I have percentages. So, to do the z-data, I'm going to just put zd, because I don't have a ton of room. Okay, so you do the p-hat, which is 0.3846 minus the p, which is 0.36, over standard deviation of 0.36, oh sorry, the square root, sorry, of 0.36 times 1 minus 0.36 over 130. Okay, so what I would do is I'd do 0.3846 minus 0.36, enter. Okay, that is 0.0246, it's showing in my calculator. Then I press divide, so it takes my answer and it divides, and I press second square root 0.36 parenthesis 1 minus 0.36 end the parenthesis divided by 130 end the parenthesis, and we get 0.5843. Okay, so I've completed step 2. I did my null and alternative, computed my test statistic using the z-data formula there, and then I compute my p-value. So the p-value, since it's a z-data, I'm going to use normal CDF. And since my test stat is in the right-hand side, I am going to go into positive E99 and then multiply by 2. So NCDF of 0.5843 to E99. Okay, do that, and we get 0.2795, but then I got to take that times 2 because it's a two-tail, so 2795 times 2 gives me the p-value of 0.5590. That's my p-value. Then I compare that to alpha. Compare that to alpha. Since it's larger than alpha, since the p-val is greater than alpha, I fail to reject the null. Means I don't have enough evidence to say that the percentage of students has changed from 36% since 2002. Alright, on to the next one. This one says in 2006 the average cost of a pizza was $8.43. We want to show that it has increased, so we sample 50 random prices and get an average price of $9.76 with a standard deviation of 145. Test the claim at the alpha equal 0.10 level of significance. Well, let's go for the null and alternative hypothesis first. So the average cost of a pizza was $8.43. That's your null. So H sub 0 is that mu, this is an average now, mu is average, 8.43. Okay, and the alternative is that it's increased. So greater than 8.43. Alright, then it says we sample 50 random pizza prices, so n is 50, and get an average price of $9.76, so x bar is $9.76, and a standard deviation of 145. Since this came from the sample of 50, this standard deviation of 145 is your S standard deviation, because it came from the sample of 50, so 145. Looking back at the formulas, that means we're going to use the blue formula here, because we have a means and the sample standard deviation. So this is going to be a t data. T data equals 8.43 minus, I got it backwards. Let me erase. Sorry. It's 9.76, the x bar, minus the mean, 8.43, over the standard deviation, which is 1.45, divided by the square root of 50. So, type that in the calculator. What I would do is 1.45 divided by a second square root of 50, get that number. That's 0.2051. And then do the 976 minus the 843, get 133. Take that 133, divide it by the 0.2051, and we get a test stat of 6.4846. Okay, so after we do the test stat, we do the p-value. So remember the p-value, since we have a right tail alternative right here, that's a right tail greater than, that means I'm going to go from my test stat, 6.4846, into E99. I'm also going to use TCDF. So let me write that I'm doing the p-value here. P-value equals TCDF of 6.4846 to E99. Okay, and then with TCDF we got to use the degrees of freedom. That's your last entry. So the degrees of freedom is always n minus 1. So that'd be 50 minus 1, 49. Type that in, and we get scientific notation. So 2.08, and I'm running out of room. E, actually it'd be 09, but whatever. E to the negative 8. So that means that you have 2.08 times 10. Oops, I should write it. I'm running out of room now. Times 10 to the negative 8. So 2.08 times 10 to the negative 8. Then we compare that p-value to alpha. It's definitely less. Anytime we have scientific notation for our p-value, it's going to be less than alpha. So since the p-value is less than alpha, we reject the null, which means we have a lot of evidence to say that the average price of a pizza has increased since 2006. Alright, last example here. One more example. Suppose you want to show that the majority of students taking public transportation suppose you want to show that the majority of students take public transportation to school, period. You sample 80 students and find that 46 use public transportation. Test the claim at the alpha equal 0.05 level of significance. Well, what's interesting about this is that we have a 46 out of 80, which is going to be a percent, but we don't actually have I didn't give you a percentage straight up in the null. However, I did give you the alternative. I want to show, that's the alternative, that the majority of students take public transportation. Majority, well, what does that mean? Majority means over half. So what I actually gave you was the alternative right away, is that P, the percentage that use public transportation, is over 50%. Come on, there's the tail for the 50. Majority means over 50%. That's what majority means. So we have the alternative, so which means we have a right tail alternative. Okay. Since we have a right tail, we're going to look at our evidence on the right-hand side. But to support the over 50%, we need to come up with a p-hat. That is, remember, we sampled, n equals 80 students, and we sampled 80 of them and got how many? 46 that use public transportation. So p-hat is 46 divided by 80. Take 46 divided by 80, and we get 0.575. So that's above 50%, and we're going to test whether or not that's significant enough. So we have to figure out what test stat we're using, and once again, since we have percentages, we're using the z-data, the purple one. So we do z-data is the 0.575 minus the 0.5, that's half, over square root of 0.5 times 1 minus 0.5 over n, which is 80. Alright, so type this in. This is the way I would do it. I would do 0.575 minus 0.5, enter, divided by second square root 0.5, parenthesis, 1 minus 0.5, parenthesis end, divided by 80. That's the sample size, and then that's underneath the square root and that parenthesis, and we should get 1.3416 as our test stat. Okay, so now the last step we have to do, the next step we have to do is compute the p-value. So the p-value, since we're using a z-data, we go back to normal CDF and CDF. Okay, and I need to figure out which tail. Well, since I'm going in the right tail, that means I go from my test stat, 1.3416 to E99. Type that in. And you type that in and you get 0.0899. Okay. Then once you get your p-value, you're supposed to compare that to alpha. 0.0899 is larger than alpha, so we are going to fail to reject. So since the p-value is greater than alpha, we fail to reject the null. And I'm running out of room. So now remember, the steps here are going to be something that you have to remember. You're going to have to get your alternative to label it what tail you're looking in. Compute your test statistic. The formulas for the test statistic will be given to you. After that, you need to compute the p-value. Once you have the p-value using TCDF or normal CDF, you're supposed to compare that to alpha, If p-value is less than alpha, you reject. P-value is greater than alpha, you fail to reject. Those are the things you have to remember. And in each case, it's a pretty straightforward process, about 4 steps to each problem. Good luck.